Hello and welcome to today's virtual briefing. I'm Greg Williams, I'm the editor of Wired. Today we explore the rise of robot workforces and investigate the social impact of automation. I'm delighted to be joined by Ran Poliakine. Ran is a seasoned entrepreneur who's founded several companies designed to address modern healthcare challenges, including medical imaging company Nanox and female health tech company Illumigen. In 2019, Ran took his robotics and AI company, SixAI, and spearheaded a new joint venture with transportation equipment manufacturer Musashi Seimitsu to create MusashiAI. MusashiAI designs and manufactures AI-based robotics, specializing in visual quality inspection for manufacturing, and is the world's first robot employment agency. And we'll be digging into what that means in a little bit. Ran, welcome. Wonderful to have you with us today.
Thank you.
Just to start off, I'm really intrigued to know, obviously artificial intelligence is a general purpose technology. It can be used in a vast array of scenarios. Tell us how MusashiAI is primarily deploying it.
Okay, I mean, in terms of background, AI technology is very versatile, like you said. Basically, we can teach the machine to do something that is very similar to what human being is doing. And because of that, you can see AI in many industries. Basically, what we've done in MusashiAI, we've been looking at those areas in the factory that are suffering from the following. There is a very tedious work that cannot be done by robot today. There are people doing it, and we thought to ourselves that if we could teach the robot how to think like a human, we can actually solve a huge problem because it's a terrible work for people, for instance, checking all day long one part, very tedious work.
So you're talking about very complex environments, right? These are factories, lots going on. What are the primary challenges that you face when you're deploying this kind of robotic technology, in this kind of an environment?
Yeah, so I think basically when you want to get into AI in general, but specifically AI and robotics, you need to answer three questions first. Number one, can the machine do the job as good or even better than a human being? Okay. Number two, can the machine with the AI do the work alongside the human being? Because it's not that all of a sudden there are no human being in the factory. And number three, can this be integrated as a natural workflow on the production floor? And I think and this is a very key point because it's useless to have some crazy technology that cannot work alongside people, but you have people in the factory. Or if you need to clear out everything from the factory floor in order to allow the robots to do their thing, and then human cannot, every different change will distract the robot, then it's also not good. And finally, if the robot is not doing as good job, to the very least, as a human being, you're dead, basically. So I think in our case, the biggest challenge, first and foremost, was really to try and prove for the first time that AI with our robot that you see in the back behind me can actually do a job that is as good as human being. And this is in terms of two factors. Number one, it should be quick. I mean, for an inspection employee at the production line of an automotive industry, when they're holding a part, it takes them no more than 2 seconds actually to be in a position that they know if it's affected or not. Okay, it's very hard for artificial intelligence to look at all the possibilities and come back with an answer within 2 seconds. And the second point should be that the what we call the recall, or what we call the accuracy level, is very high. Because, for instance, in the automotive industry, there is no room for mistake. I mean, one defective part going into a car can cause a recall of a whole line of cars. So this was the first challenge that I'm very happy to say that in MusashiAI, with a combination of technology from Japan and Israel, we managed to meet this incredible demand. So that's number one. Number two is really about how will it work human and robots alongside. And we tested that, and in our production line in Japan, we tested different scenarios of many people, small amount of robots, many robots, small amount of people. So this is like a social observation, and we came to the conclusion that there is no problem. And like today, there are a lot of automation in the production line. Those robots are automation, but with a human brain in a way. So that's what we did. And finally, it's of course something that has to do with the flow. You need to make sure that the rhythm and the flow of the production process is actually meeting the rhythm of the robot. So that's something we did as well.
It's got to be there's got to be a synchronous kind of environment.
Yeah, I mean, one of our products, I think you know, is a forklift. And so think about the forklift that has no drivers, and now the forklift is getting a task. Hey, can you get this box from here to there? Only on the way, Mr. Joe or some people from accounting are crossing by, and some other employee put something on the floor. So how does it work all together? And you need to make sure that there is a master planner that can take care not only on the robots, but also consider humans and other things that are on the floor and take decisions based on that.
So clearly there's going to be, I think, the coronavirus crisis will mean, I think, a lot of large organizations are going to start looking increasingly at automation, increasingly at robotics. What advice do you have in particular for manufacturers when they're thinking about assimilating robots and human beings in a working environment?
You know what, I want to give you an example from a different industry in the context of COVID-19. I mean, if you think about healthcare and remote diagnostic, I mean, in many countries up to the COVID-19, the idea that the patient will talk remotely with a physician was forbidden, regulated wise and otherwise, and all of a sudden, many countries just open it because it's part of life and because they realize that the technology is there. The same way, I think that COVID-19 telling us that we need to do something different. So my advice for those companies will be, guys, AI robotics is here. It's not a futuristic idea, and let's go for it. Just be open to it. Small, we can start in a small hangar, see how it works, and then expansion. I do believe that with MusashiAI, but also with other companies that are getting into this, you will find out that many of those AI robotics workforce, like I like to call them, will be part of our life in the very near future in mass deployment.
I'm interested to get a sense of this idea, though, of assimilating machines and human beings. How do you overcome maybe that fear that maybe some of the human beings have of working with this kind of robotics?
Well, I think first of all, you need to ask yourself what the technology can do. That's question number one. But not less importantly, question number two, you need to ask yourself, what do you want the robots to do? Because the fact that the robots can do something doesn't mean that this work is not designated to be a human work. And I think this is a tricky area. So I don't want to be too much philosophical here, but I think this is a key question because we've demonstrated that technology can do far more than what than sometimes what we expect. But for instance, if you're trying to go for the industry of caregiving for elderly community, is it not better that you have a human touch rather than a robot that can do maybe efficiently, can take care of the older person? And I think that's the key question. So it seems to me like in our case, in the factory that is already predominated by machineries, and the work that we have identified for those robots are work that you don't want people to do because they are terrible works, actually. Those are the places that technology can help. However, in other places like taking care of people, old people, education, and places where human touch is needed, I do believe that even if the technology can do a job or the job, you rather have a human take care of this task.
Sure. No, that makes a lot of sense. So one of the innovations that you've driven is Inspector. Do you want to talk us a little bit through that? Because I think it's a really interesting thing to discuss with the audience.
Sure. So, I'll give you some facts which are amazing. Let's take Japan for, Japan is a superpower of car manufacturing. And there are about 8 million people working in the industry. This industry is heavily automated. There are a lot of robots and a lot of automation machines in this industry. However, 40% of the workforce are doing two different things. 20% of the workforce, which is 1.6 million people in Japan only, are doing all day long this. Basically, they're taking parts from the tray, they're looking. In their brain, they need to define 27 different families of defected and come to the conclusion whether this part is defected or not. Now remember, if they are failing in this part may go into a car that will be breaking down during driving, and that can be either a safety issue or a major recall anyways. So they're doing this, I don't know how many thousands times per shift, pick up the part, look at it, in this computer in the head, 27 different families of defected. They need to determine, okay, it's fine or not. This is a very, very difficult job. And especially if this factory is working 2 shifts. So 1.6 million people in Japan only doing all of that. Now, this is not because people did not try to solve this problem, but rather because it's very difficult to determine within 2 seconds whether you have a defect or not. So our approach was, okay, this is, I'm now serving as a robot. This is my hands. These are robotics. This is already solved, because there are many robots that can move 6 axes, I believe. So this already we took care. I can take a part as a robot, just like a human, and put it in front of, instead of eyes, in front of a camera, okay? Now this camera is observing or acquiring the images that very quickly going into a CPU, which is an AI CPU that needs to run algorithms that are imitating what's going on in my head. Now, what's going on in my head is not, a huge amount of all the defects images, and so I'm not comparing in my head. I'm actually drawing a conclusion based on what we call neural network. And that was a challenge that we had. So instead of comparing with, this part with a defected part, which is an impossible task to do because there are so many defect parts out of 27 families, we try to teach the AI algorithm to behave like our brain. And that's a very, very interesting process that, we successfully completed. But that's really what's going on. So the mechanics of the human being is the robotics. That's already sorted out. The optics are the eyes. So we are looking, by the way, our eyes are very, very sophisticated, and the resolution is endless, basically. So what we did when we move it to robotics, we need to define a wavelength that is best suited to identify the defects. And then the computer, my brain, is actually going to an AI algorithm that is running on a local CPU. By the way, local CPU, we call it edge computing. That's very...
I'm going to ask you about edge computing. How important is edge computing to the deployment of robotics for you?
No, I think it's critical, and it's very interesting that the transition. I mean, at the beginning, if you recall, there was one big IBM computer and many slaved monitors, right? I think it's called the original IBM computer was a huge piece of equipment the size of this room, and there were many terminals. The terminals were stupid. The brain was in the IBM computer. Fast forward. Every mobile device and every laptop, every desktop has CPU inside that can do the calculation needed. But then the internet came, and the internet introduced the cloud idea, putting in the cloud huge amount of processing power, and by that getting almost like a supercomputer to get very complex questions answered very quickly. And then the next one is closing the loop is people realize that if you have something that is very urgent and you want to do it locally, you actually want the computer back in the production floor, because you cannot always trust the internet to work, nor do you want your local data to go all the way to the cloud and come back. So this is where edge computing came back. So it's very interesting to look at the cycle of, in a way, the IBM computer, original one, representing the cloud, so one central processing power, and then the let's say Apple and Dell brought the processing power to us in the personal computing. Then the internet brought everything back to the cloud, and now edge computing is actually taking it back down to the production floor, which I believe is a critical component in the Industry 4.0, which is talking about really transforming the industry, the industrial places with AI and robotics.
So I'm intrigued to get a sense from you. If so many of the robots are relying on edge computing, this is obviously a very complex series of maneuvers that are going on throughout the factory floor. Can you talk us a little bit about how you implement fleet management, the fleet management system, if you like?
Sure. So I think, first of all, edge computing needs to be very strong and powerful like the human brain. However, as you well know, most of our day we're not utilizing most of our power in our brain. Okay, we have this neural network that can allow us to come to a conclusion without utilizing in a big way the total processing power. And I think the key is really how to optimize the use of CPU in this edge computing. That's put that aside. What we're doing with the fleet management is very simple. Instead of everybody's talking about autonomous car. Autonomous car, by definition, is a car that have all the capabilities to build the universe surrounding it, so that we will not collude into others, and we are building the map as we go, basically. So there are a lot of lidars and a lot of technology there. However, in a factory, the universe is pretty much known, okay? And the cost associated with autonomous forklift, let's call it, are significant. I mean, you don't want to spend too much money. And you also know that you have a fleet. It's not one, you have many. So how can you manage that? And for that, actually, what we did, we put an eye in the sky. In our case, eye in the sky is in the ceiling of the factory. One general ability to see everything that is going on. Not only the fleet, also people walking around, someone left a cardboard on the floor, what have you. And then this eye, this optics, getting all this information into one edge computing that is managing the algorithm that come to conclusion. And the conclusion can be, okay, forklift number one, go to point number B, forklift number two, hold on, someone is crossing, stay, and then go, okay? And all of that is actually connected to the ERP, which is a major thing in real business. I mean, okay, so that's another point. So that's what we did, basically. Our system is basically taking the advantage of ERP and universe that is known, which is basically factory landscape, alongside with a very, I would say, parallel AI algorithm that enable us to multitask in a way when you have many, many elements that you throw into the situation. So we did that. That's technologically it's working, but I think the more important thing, there are two elements. One is this is already connected to the ERP, which is a prerequisite in my opinion when you're talking about industrial scenario. Number one. Number two, the total cost of ownership is very, very low because the forklifts are not as expensive as the autonomous forklift. They can be, going back to the IBM and terminal, they are the terminal. Basically, you're looking at each one of the dummy forklifts from the sky and direct them where to go, which is a very, very different architecture than what I think the industry have seen so far.
Well, I mean, you mentioned that the costs are low. What kind of impact, can you give us a sense, what kind of impact does this have on costs?
Yeah, let me tell you our approach, which is, I think, even more interesting, in my opinion, at least. Our approach is that whatever we do, we need to make sure that the total cost of ownership to the business will not exceed the employee that is doing this job. So the approach is, if I have an employee in a forklift that the employee is going all day long, moving things from here to here, whatever I do, I should not allow the cost of the delivery of our robots to be more than in, let's call it, monthly salary of an employee.
Right. So do you think it's fair to say that, we've talked about, software as a service for many years now. Are we entering the era of robotics as a service? Are we entering the era of ROS?
Absolutely. ROS, yeah. Robot as a service, yeah. Absolutely, yes. I think it's not only because of the fact that technology enabling that, but more importantly because the fact that I think the businesses are used to pay for software. They're used to pay for OPEX and not CAPEX. It's much easier for them. So robot as a service can be integrated seamlessly into their monthly budgets without any pain. And that's a key point of barrier to entry, that if you overcome, you can see this robot as a service everywhere quickly.
Yeah, yeah. And a lot of the debate around automation and robotics at the moment is the focus that people have on how the workplace is going to change and the roles, frankly, of human beings. Do you see a future in which human beings are displaced and they move to other roles? Or do you see a future where human beings will have very different kinds of lives to the ones they have now, and we'll have to introduce things like something UBI so that human beings can actually, have a living, have some kind of form of income?
Yeah, I think, again, holistically, I think that some smart people need to sit down and decide which work we want humans to keep doing in our future society, because it's very clear that technology will enable us to do many things. Now, so I think that's a key question. In our specific case, in MusashiAI, I can assure you that the robots that we've created are doing a good job by replacing those human beings, because they can go and find other things that has to do with human touch, much easier jobs that will enable them to have a very good life, rather than sitting all day long looking at those thousands of parts with such big responsibilities. So I think that, again, holistically, I think that's a question that we need to definitely to address. What do we want people continue to do? And specifically in our case, those two robots that we build are actually liberating in some ways those employees from doing some very, very hard and tedious work, and enabling them, even in the same factory, to go and do something that are much more pleasant, creative, and areas where human touch are really needed, actually.
So it's more creative work, and the idea is augmentation rather than replacement, if that makes sense.
Absolutely. I mean, again, going back to Japan, because this is where the origin of this technology came from. As you know, Japan has a huge amount of elderly community. And even though the federal government, allowing for so many technology to go into the houses of those older people, it is very, very clear that there is no replacement for a human being that will take care of those old people or also sick people. So I think this is an area that there is a huge demand, not enough caregivers. And if we can liberate the people from the factories from doing this all day to go and help some older person or a sick person, I think this is a good cause. Absolutely.
You mentioned healthcare and robotics and AI. Clearly it's being implemented in Japan already because they have obviously the demographic challenges of an aging population. Are there any other industries where you can see a real application of robotics and automation in the coming years?
Yeah, well, I think it is my opinion again that let me tell you what me personally, what I rather not see going into. Okay, I would not like to see robotic AI teachers in a classroom of my kids. I would rather have a human teacher teaching them going through the experience with them. This is one area. The other area is, of course, the healthcare and the caregiving. I think it's absolutely necessary that people will be treated by people, especially when they are alone, etc. I do think that every place where you're making something, like the food supplement, food tech, drugs, everything that you're making, I think you'll see more and more quality assurance robots, in my opinion, that can bring some of the smart of human being and liberate those people from a terrible work. Yeah, that's about it. Yeah.
So yeah, it's those kind of back of the house rather front of the house kind of tasks that probably robotics. Whereas we need those human qualities in the areas like healthcare, and I think probably something like retail as well, where those human qualities are so powerful. Ran, we're pretty much out of time now, but I'm really interested to ask a final question, which is, I know that you're a big believer, a big supporter of you're an impact investor. How do you think, just, a big question, how best can we deploy AI so that we can have, an impact on humanity, but also the planet as well?
Yeah, well, I think in order to to implement in a sufficient way AI, and this is actually, I'm addressing entrepreneur actually. I do believe that don't try to solve a problem if there is not a problem already there. So always try to start from a pain. That's number one. Number two, technology is only the means to an end. I think implementing this AI into the process and understanding the culture and the barriers in the business flow is a key to adoption. So in other words, what I'm trying to explain is that technology is already there. Technology is not really the issue. How to bridge between technology and business processes, technology to workflows, is what I think people need to put attention on. That's kind of my small answer to a big question.
You know what? Sometimes small answers are the most powerful ones. Ran, thank you so much for your time today, for sharing your insight. Thank you to everyone for watching this session. If you did enjoy today's session, please do look at more of our Wired virtual briefings on business, technology, politics and science at wired.co.uk. In the meantime, stay well, everyone, and we'll see you soon.
Thank you.